Let's now discuss how you would find the domain of a function that has a variable in the denominator. The domain of a function will have restrictions if there is a variable in the denominator, since the denominator cannot equal 0. So when we divide 20 by 4, this is equal to 5. So we can have a positive real number in the denominator and get a real number as a quotient. The number in the denominator can be negative. 20 divided by negative 4 is equal to negative 5. So we can divide by a positive number or a negative number, but we cannot divide by 0. This will make the quotient undefined. So in this example, f of x is equal to 5 divided by x minus 4. X cannot equal 4, because if it did, then we would have f of 4 is equal to 5 divided by 4 minus 4, and that would be equal to 0. And then 5 divided by 0 would be undefined. So in your domain, x can equal any number, but it cannot equal 4, because that is the one number that will result in 0. So the domain is all real numbers except 4. Okay, so that's the logic of how we find the domain when a variable is in the denominator. The domain of the function will be all real numbers less than the restricted number, and all of the real numbers greater than the restricted number. So in our case, where x cannot equal 4, it is all the numbers from negative infinity up to 4, but not including 4. So the first interval would be from negative infinity as the first entry, and positive 4 as the second entry. Parenthesis to the right, since 4 is not included. A u between the intervals, and then the second interval is from 4 to positive infinity. So in the current example, this would be the domain. This is the same as writing all numbers except 4. This is what that would look like in interval notation. If it were a different number, same thing. If it's all real numbers except for 2, the domain would be from negative infinity to 2, and then from 2 to positive infinity. This is the way of saying it's any of these numbers except here. This creates 2 separate intervals. So this would be the general form of when the domain is restricted by just one number. But as we saw earlier in the chapter, the domain may be restricted by several numbers. So if there were a second number, for example, this then creates 3 unique intervals. So the domain would represent that: the first interval, u, the second interval, another u, and then the third interval. So let's walk through an example together. Let's say you're asked to find the domain of f of x, which is equal to 2 divided by 3x plus 6. So we are going to focus on the denominator, since this is where the restrictions will come. So step 1, set the denominator equal to 0. So the denominator is 3x plus 6. So we have 3x plus 6 is equal to 0. And now step 2, we want to solve for x. So the first thing we do is subtract 6 from both sides, giving us 3x is equal to 0 minus 6, which is negative 6. And now to remove this coefficient, positive 3, we want to divide both sides by 3, showing us that x is equal to negative 6 divided by 3, which is negative 2. So this shows us the number that x really cannot equal. When x is equal to negative 2, this is when 3x plus 6 is equal to 0. So this is the number we are trying to avoid. So the domain would be from negative infinity to negative 2, parenthesis to the right, since negative 2 is not included, a u, and then the second interval would be from negative 2 to positive infinity, parentheses as well, since infinity is not a real number, and negative 2 is not included. So that is how we go about finding the domain when we have a variable in the denominator. Let's now have you complete a few practice questions. Question number 1. Find the domain of f of x is equal to 7 divided by x plus 3. Question number 2. Find the domain of g of x is equal to 2 divided by x squared minus 4. And question number 3. Find the domain of h of x is equal to 2x divided by x squared minus 4x minus 5. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We had f of x is equal to 7 divided by x plus 3. So step 1, set the denominator equal to 0. And then step 2, solve for x. So we'll do so by subtracting 3 from both sides. So we see that the denominator is equal to 0 when x is equal to negative 3. So the domain is all real numbers except for negative 3. So this would be the domain for f of x. The first interval is from negative infinity to negative 3, parentheses around both, a u in between, and then the second interval, negative 3 to positive infinity, and this represents all real numbers except for negative 3. So that is the answer to question number 1. Let's now have a look at question number 2. G of x is equal to 2 divided by x squared minus 4. So step 1, set the denominator equal to 0. And then solve for x. So we'll start by adding 4 to both sides, giving us x squared is equal to 0 plus 4, which is 4. And now to remove this exponent 2, we want to find the square root of both sides. And the square root of 4 is equal to negative 2 or positive 2. So for this domain, it's all real numbers except for negative 2 and positive 2. Negative 2 squared would be 4. 4 minus 4 would be 0. And positive 2 squared would be 4, also leading to 0. So that is why both numbers are included. So the domain, we have one interval from negative infinity to negative 2, a second interval from negative 2 to positive 2, and a third interval from 2 to infinity, and parentheses around each set of numbers. So that is the answer to question number 2. Let's now have a look at question number 3. H of x is equal to 2x divided by x squared minus 4x minus 5. The numerator, we don't have any restrictions with this variable x, since let's say we didn't have the denominator. If it were just 2x, there's no number, positive or negative, that x could equal that would make 2x undefined. You would always get a real number if you plugged in negative or positive numbers for this x. So that is why we continue to focus on the denominator in this example, even though we have an x in the numerator. So we set the denominator equal to 0, but now we will need to factor this expression. So we need to find a pair of numbers that have a product of negative 5 and a sum of negative 4, and that would be negative 5 and positive 1. So x plus 1 times x minus 5 is equal to 0. And now we want to set each factor equal to 0 and solve for x. So x plus 1 is equal to 0. We want to subtract 1 from both sides. So when x is equal to negative 1, the first factor would equal 0. And if either factor equals 0, then the entire expression equals 0. So in our domain, negative 1 is not included, since that would make the factor equal to 0. This second factor, x minus 5 is equal to 0. We add 5 to both sides, showing us that we want to avoid x is equal to 5, because that would make the second factor equal to 0. So the domain for h of x, the first interval is from negative infinity to -1. The second interval is from -1 to 5. And the third interval is from 5 to infinity. Parentheses around the numbers since they are not included.